In this video, we're going to compute the following integral. So we're going to call it I. It's the integral between 0 and 2 of the maximum of these three functions, x, square root of x, and x squared. Here, the maximum means the bigger one of these three. We'll make it simple, okay? And we remember that if we have the two numbers a and b, then the maximum of a, b is a if a is bigger than b. Okay? So that's the same thing here. We can also define that for two functions. Okay? So the maximum of two functions, if f is bigger than g, let's say the maximum of fg is f of x is if f of x is bigger than g of x in some interval. Okay? Sometimes this maximum can be, let's say, this on some a, b. Okay? Sometimes the maximum can't be on the whole interval. It can be on some separate interval. And therefore, we need to take that into account. Okay? One of those cases is the functions sine x and cosine x. Okay? If we want to find the maximum of these two on this interval, 0 pi, okay, we know that these two are equal when x is pi over 4. Okay, and we know that the cosine is bigger than the sine on the interval 0 pi over 4. Okay, and for the others, we will treat them by just looking at the values. Okay, comparing the values of the sine and the cosine, or we graph the sine and the cosine on the same graph, and we see from there. Okay, anyways, this is just a simple way of remembering or the definition of the maximum. Okay, so anyways, the maximum of two things is the bigger one. Okay, in our case here we have 3, not 2. Okay, I think the easiest way to solve this one here is we can graph these three functions, okay, on this interval 0, 2, and from there we see which one is bigger. That's the easiest way. Okay, there is another way if you want to do it. If you can check that, we can check that the maximum of a and b is a plus b plus a minus b in absolute value over 2. Okay, you can check that. And from here we can use recursion to define for 3 elements. But for us, we just want to graph these 3 functions on the same graph, on the same paper, and see which one is bigger on 0, 2. Okay, so we know how to graph x, square root of x, and x squared. Let's do that, but we have to be careful. Okay, one thing to note is that when x is 1, all these 3 functions are the same. They have the same value, which is 1. So here, 1, so this is x equals 1. Okay, when x is 0, all the 3 are 0. Okay, so we know the graph of x. Okay, so this is this segment here, or the line. Okay, on this interval 0, 1, okay, we know that x squared is less than x. Okay. Okay, and we know that outside of this interval, x squared is bigger than x. So here we have x squared. Okay, so on this interval 0, 1, x is bigger than x squared. Now the square root is bigger than both of these on this interval 0, 1, and it's less than these 2 on outside of this interval. Okay, now we see what we want. Here, this is my interval 2. On 0, 1, the maximum is the square root. On 1, 2, the maximum is x squared. And therefore, I can split my integral I Okay, so here the integral between 0 and 2 of the maximum of x squared of x squared dx. So this one will be the integral between 0 and 1, and this is because of the linearity of the integral. Here between 0 and 1, the maximum of these three is the square root of x. Now between 1 and 2, the maximum is x squared. We see it graphically here. So let me write this one. This is y equal x. This is y equals square root of x. Okay, so here between 0 and 1, this is the square root of x. Between 1 and 2, this is x squared, which is winning here. And now I know how to evaluate these values. Okay, I know how to do that. So this is just 2 over 3 plus 1 over 3 x cubed between 1 and 2, and 2 over 3 plus 8 over 3 minus 1 over 3. So it's going to give me 8 or 10 minus, so 9 over 3, which is 3. So therefore, my value of this integral is 3. So I, in this case, is 3. Okay? And if we see that, we can see that here. So this is my integral. Okay, I think I need to change this. So this is the area, because this one is positive. Okay, so this is one way of doing it. Otherwise, we'll have to deal with this one here, but this is enough. Okay, so graphically, if we can find graphically or prove graphically the values that we need, or finding the maximum that we need, this is perfect for me. That's what we can do. Okay, if you see any errors or mistakes, please let me know. Thank you.